The laws of chemical combinations created ripples in the standard pole of chemistry. They enable scientists to carry out various experiments that helped in forming strong foundations in chemistry. However, the laws still needed experimental evidences and proofs. Only then with accepted. It was around the first decade of 19th century. The chemist and physicist from England named John Dalton was successful in considering many questions. He proposed a theory which was then known as the Dalton's atomic theory. With this theory, many concepts regarding matter, composition of matter, atoms and even combinations of atoms resulting in compounds will better understood. Okay, let us first check a clear look as the 6 major postulates of his theory. First, he said that all matter is made up of very tiny particles called atoms. Secondly, he suggested that atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Third postulate was atoms of a given element are identical in mass and chemical properties. Similarly, fourth postulates that was atoms of different elements have different masses and chemical properties. Fifth postulate stated that atoms combine in a ratio of small whole number to form compounds. And lastly, the relative number and kinds of atoms are constant in a given compound. Let us understand each postulates one by one by taking the same examples of element A and element B given rise to compound C. The first point stated that all matter is made up of very tiny particles called atoms. It means that when we go on dividing the matter into smaller and smaller sections, what we get at the end is atoms. Can we say that element A and B are made up of atoms? Yes. In fact, compound C is also made up of atoms that have combined together. So the first postulate was very easy to understand. The second postulate was that atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Now, what do you mean by this? Yes, it means that atoms are like the fundamental units. Dividing them further is not possible. Also, in a chemical reaction, atoms may combine together and forming as a new units. However, no new atoms can be created and existing ones cannot be destroyed. So in this case, atoms of elements A and B are just combining to form compound C. Can we say that no new atoms are formed in this case? Yes. And similarly, no atoms is destroyed. Let's move on to the third one. The third postulate states atoms of given elements are identical in mass and chemical properties. If we zoom into element A, we find all the atoms that make up element A are just the same. And in what sense they are in same? The atoms have identical mass as well as chemical properties. In simple words, the third postulate states that all atoms of a given element are identical. Does this explain the fourth postulate too? Yes, The fourth postulate states atoms of different elements have different masses and chemical properties. So, are we able to notice that atoms in element A are different from those in element B? Absolutely. And in what sense they are different? Atoms in element A and B have different masses, even different chemical properties. In simple words, it states that atoms of different elements are different. The fifth postulate states that its atoms combined in a ratio of small whole number to form compounds. Now, what do you mean by this? In this chemical reaction, we find elements A and B reacting and giving us compound C. If we observe well, the unit of compound C has 2 atoms of element A and 1 atom of element B, right? So on these whole numbers, this means that any compound, the elements are always present in a ratio which compress of whole numbers. You will not find half or 3/4 atom combining with the other. In case of water, we always have 2 hydrogen atoms and 1 oxygen atom combining to form 1 unit. In 1 unit of carbon dioxide, we have 1 carbon and 2 oxygen atoms. This same holds true for all compounds. The number of atoms of a particular element in a compound will always be a whole number. Now for the last one, the sixth postulate states that the relative number and kinds of atom are constant in a given compound. This same explanation that compound C has 2 atoms of element A and 1 of element B makes us understanding. Yes, if we scan compound C, we will always find 2 atoms of element A, 1 atom of element B in a single unit. This is applicable for all compounds. We already looked at 2 examples, water and carbon dioxide. In case of 1 unit of water, we always have 2 hydrogen atoms and 1 oxygen atoms. And in a single unit of carbon dioxide, we have 1 carbon and 2 oxygen atoms. Carbon monoxide has atoms of each, that is carbon and oxygen. Okay, so while 1 unit of ammonia always have 1 nitrogen atom bond with 3 hydrogen atoms. So the number of atoms will always be constant in a unit of a particular compound. All these postulates help chemists to further understand the behavior of elements and compounds from them. But for understanding these elements and compounds, knowing the concepts of atoms is necessary. Let's get to know what exactly these atoms are, how they exist, atomic mass, and many such interesting concepts in the upcoming videos. Thank you. Thanks for watching the video.